All right, so we're going to move right along here, and we're going to be dealing with Hess's law. Hess's law, a lot of S's in a row here. Anyhow, Hess's law, it deals with adding reactions together. So some reactions don't, when they go forward, they don't produce and make a product of something that is going to stay in that form. So it may continue to reacting with something else to get what the real product is. So we call this the net equation. So if you have 1, 2, 3, you could have multiple equations where they all produce, let's say first one produces a product, and then that product reacts with something else to produce something else, and then that product reacts with something to produce a third thing, whereas that is really what the reaction kind of wants to go to. So again, some of them are in series, and so they're added together. If a series of reactions are added together, the delta H's are added as well. So let me just show you an example. Let's say we have nitrogen in the atmosphere, and it reacts with oxygen. Okay, well that can produce nitrogen monoxide. All right, and that has a delta H of 181 kilojoules. All right, so there's a reaction. But now that NO2 is not happy, is not satisfied. It continues to react with more O2. But again, it's not a situation where the N2 just reacts with O2 to produce this product. It needs to go through that intermediary stage of that NO. But then when it reacts with more O2, then we form NO2. Okay? And so that's, I guess, the kind of stuff that we're really making. And that delta H for that one is negative 113 kilojoules. Okay, so this is actually part of what's in smog. Okay, so there's your reaction. Now if I wanted to look at my net reaction, so here's my first, here's my second, just like I have a delta H1 and a delta H2. Okay, but again, the nitrogen reacts with oxygen, but it doesn't go straight to NO2. It has to go through NO, and then it reacts with more O2 with that NO to produce the NO2. Now here's the net. If I say my net would be N2 plus O2 plus 2NO plus O2, and all I basically did was just put all my reactants on one side, and then my products, 2NO plus 2NO2. All right. Now that, I guess, is what we could call our, I don't know, gross equation, our gross ending equation, because notice I can kind of clear this up and say, well, N2 plus 2O2, because notice I have 1, 2, and then notice that the NO is going to cancel. I've got one on the reactant side and one on the product, so I can just cancel those two NOs out, and this produces 2NO2. Notice it is balanced. N2 plus 2O2 yields 2NO2. It's balanced. This is my net equation. All right. Now, that equation is combined between my first and my second, which means this delta H for this one, I don't want to have my head in the way, so the delta H for this one of my net equation is those two added up. So I bring that on down, and what is it? A positive 68 kilojoules. Okay, and so there's my net equation and the delta H for that net equation. All right, that's Hess's law. That's kind of how we look at it. All right. Now there are some things that sometimes have to be done to the equations so that the net gets does get formed. Okay, so that's what I'm going to see on the next slide.